Okay, students, we will discuss the test 2 solutions. The question numbers 1, 2, 3, the little bit easy questions. So anyway, all will discuss, all the questions I will discuss. Let us start with the question numbers 1, P1. So most of the students attempted this question and they did correct also. The first question as follows. The light reflected by a plane mirror forms the real image. We have to comment on it. So we all know that light reflected by a plane mirror forms the real image only for the virtual object. So only for the virtual object. That is true if it is converging nature. Okay. So if the light rays are converging at a particular point, then it forms the real image. Let us see the P1 question. So this is the plane mirror. Let's say this is the plane mirror. So I'll draw a normal. Now the light rays which are coming from infinity, let's say this is the light ray which is coming from infinity. If this mirror is not there, it's supposed to meet here, the converging point. Converging point. So this is the virtual object. Now they'll be reflected. They'll follow the laws of reflection. They meet here. This is the reflected. This is the real image. So that means for virtual object, real image is formed. For real image, it will not form the real object. Let's say, for example, I'll take the real object. Let's say object is placed here. This is the real object. The rays are falling on the mirror, then they will be reflected. So they will meet finally here. Virtual image. Okay. So it forms the real object. For real object, we'll get the virtual image. Okay, fine. The answer which matches will be here, the B option. So go for the second question. The second question, the object is placed between the two mirrors symmetrically. The two mirrors will be there, and the object is placed symmetrically at an angle of, the object is placed here. This angle is of total angle is 72 degree. The number of images formed will be decided by 360 by theta quantity. So let's say 360 upon theta will be 72. It will come as 5. So as it is placed symmetrically, so the number of images will be is equal to 5 minus 1, that will be is equal to 4. The option will be the C is correct. Okay, fine. Now let us go for the third question. The question number 3, P3. A man of height h requires, let's say there is a man standing in front of a plane mirror. This is the feet of the man, these are the eyes of the man, and this is the head of the man. Let us call this distance is B, and let us call this distance is A. Now the mirror must be placed here. Mirror must be placed here, which is at a height of A by 2. And its height must be, the height of the mirror must be A plus B by 2 to see the complete image, which is from feet to neck. Okay, this is the minimum height is required. So the minimum height is required is height of the person, if I take is h, the height of the person is h, the minimum height required will be h by 2. Okay, this is h by 2 is the minimum height is required. This I have done already in the class. Okay, you can go through the class notes also. So h by 2, this is the C option will be correct. The best option will be here, C option. Now let us go for the next question. So P4, the question P4 as follows. A light ray incident at the angle 50 degrees on the middle of the two mirrors. Let's say I have the two mirrors which are inclined like this. This is the mirror 1 and this is the mirror 2. The angle between them is given in the problem is 50 degrees. Sorry, 60 degrees. The angle between the mirrors is 60 degrees. So a ray of light is incident here. A ray of light is incident at an angle of 50. Then there is a reflected light. Then there is a reflected light that is also 50. Now, as it is a normal, definitely this is 40 degrees. This is definitely 40 degrees. 60, 40 will be 100 and this will be of 80 degrees. Because total will be 180 degrees. Now I draw a normals. Definitely I need to draw the normal. Let us draw the normal will be here, which makes 90 degrees. So the 90. As this total angle is 90, definitely this angle is 10 degrees. Now a light ray is coming and falling at an angle 10 degree. When the light ray is falling at an 10 degree, then there is a reflected light. The reflected light is also of 10 degree. So reflected light is also of 10 degree. This is also of 10 degree. Now this ray is after reflection, according to the problem, again falls on the first mirror. Let's say this is the normal again here. Don't forget the normals. This is the one normal, this is another normal. This is the normals. Now calculate the total angle. So this is the triangle again. So in the triangle, this is the angle 20 degrees and this is the angle 100 and 140. 140 plus 20, 160. So this must be 20. So that it will become 180. Now what is this angle? As it is 90, this must be 70. So now the incident angle will be of 70 degrees. So the best option will be the C option. The first, it is falling here. This is the first ray which is coming. Then this is the first reflection. Then this is the second reflection here. Then after second reflection, this is third reflection supposed to occur. Then again this angle is 70 degrees. Okay, fine. So next move to the fifth problem. So this is the fifth problem they are asking. In the fifth problem, the focal length of a concave mirror is f and the distance from the focus to the principal focus to the object is x. So object distance from the focus, they are measuring from the focus. From the focus, if the object distance is x and the image distance is y, then we have the relation xy is equal to f square. Okay, when I measure. So if the same thing is measured from the pole of the mirror, the relation will be object is located at u and image is located at v. The relation is 1 by v plus 1 by u is equal to 1 by f. That can be written as 2 by r. So the relation we have. Okay. So in this problem, they are asking the magnification. Let us talk about the magnitude of transverse magnification that is decided by the v by u. So v in this problem, we need to measure from the focus instead of the pole. This is the pole and this is the focus. This is the f. There is the object distance. There is the image distance. So object distance will be given as this is x and image distance this is given as y. When I measure from the pole, this will become f plus y divided by f plus x. From here, what I can write for y? So y is equal to f square by x. So that will be equal to f plus f square by x, f plus x. So if I take, it will be xf divided by f square divided by x into f plus x. So take the common f above, then remaining is x plus f. Here is already x outside, then f plus x. Cancel with each other, then it will be equal to f by x. Then what is the best answer will be? The best answer will be the B option. Okay. So this is the Newton formula. This is called as the Newton mirror formula. Okay. Remember that. Go for the P6. The P6 problem, it is again based on the Newton formula. Object distance is measured from the focus is x1 and image distance from the focus is s2. Then that is equal to f square. From this, they are asking the focal length, that will be is equal to square root of x1, x2. Okay, this is the P6. Let us go for the P7th problem. It is also a nice problem. So it will be the P7th problem. So an object of 1 centimeter is placed 4 centimeters in front of a mirror, and they did not mention what type of mirror it is, and but they have given that key in order to produce an upright image. So the nature of the object and the nature of the image will be the same here, upright image. If this is a 1 centimeter, these are given, this is a 3 centimeters. It became the 3 centimeters. In case of mirror, transverse magnification is height of image by height of object, that is equal to minus V by U. So height of image is plus 3 and height of object is plus 1, that is equal to minus V nature divided by U is given as minus 4. I don't know what is the V nature. It is given as minus 4 in front of the mirror. So minus minus plus, it will become 12. So V is equal to 12 centimeter it is coming. If B is equal to 12 centimeter, that is plus 12 centimeter we are getting. So that means if I call it the mirror here, this is the region where the mirror is placed. This is the mirror. What type of mirror, that I don't know. The image will be formed here. So not here. So that means I'll erase with the, I'll erase with this. The image will be formed. So image will be formed here. That is of 3 centimeters. That is of 3 centimeters, right? So the object distance is 4, that is minus 4. Then here it is obviously V is coming as plus 12. Now I'll apply 1 by V minus 1 by U is equal to 1 by F formula. So 1 by V, that is plus 12, minus 1 by U is minus 4. That will be is equal to 1 by F. So 1 by 12 plus 1 by 4 is equal, 1 by V plus 1 by U. So the plus. So this is a minus. So I'll erase with the pencil. Mirror equation, there is a plus symbol. 1 by V plus 1 by U. So there is a plus symbol it is. There is a plus symbol here. So that I have minus, that is equal to 1 by 5. Multiply with 3, divide with 3. Then I'll have 1 minus 3 by 12 is equal to 1 by F. So minus 2 by 12 is equal to 1 by F. So focal length is equal to minus 6 centimeters. Minus ochindi ante this will be concave. This will be concave and decide one. Once it is a concave mirror, then radius of curvature will become 2 times of it. The radius of curvature will be equal to 12 centimeters. Concave mirror of radius of curvature 12 centimeters. So negative ochindante concave mirror. So after that manaku nature teliyadu. So finally it is a concave mirror. So focus will be of 6 centimeters. So this is the pole and this is the focus, and object is placed in between the pole and focus. So the object of height 1 centimeters. కాబట్టి మనకి ఇమేజ్ ఇక్కడ ఫామ్ అవుతుంది, వర్చువల్ ఇమేజ్ of 3 centimeters. Okay, so this is the story about the P7. The best answer will match here, concave mirror of radius. That is the B option will be the correct option. Okay, next to go for the P8. P8. So the matrix, this is the matrix type. The first matrix, column 1 indicates the position of the object, column 2 the magnification. The first they have given an object is placed at the focus before a convex mirror. Let us take a convex mirror. This is the convex mirror, and object is placed before the pole. This is here, object is placed, which is at a distance of the focus. Apply the mirror equation. 1 by v plus 1 by u is equal to 1 by f. 1 by v that I don't know, plus 1 by f is, that is minus f, that is 1 by f plus f. Go this side, then it is become 2 by f, then v will become f by 2 plus f by 2. So image will be formed here plus. So magnification is minus v by u. This is minus, and v is f by 2 and u is minus f, that is 1 by 2. Magnification is 0.5. This best suits with the match. Then match out the, so it matches with the B option. Now let us, so here B option is there in the two, A answer and as well as D answer. Let us go for another one to cross check. So I am going for the second one, that is of an object is placed at the center of curvature of a conical mirror. If any object is placed at the center of, an image is formed at the center itself. So object is placed at the center, then image also formed there only. So if the object is of height 1 cm, object, then image will be of the same size is formed there only, but inverted. This is the image. This is the height of the object, and this is the height of the image. But height of the image is opposite to that of height of the object. So magnification will be of -1. So this best matches with the -1 is there in the D option. So if you observe, first one goes to B and second one goes to D. First one goes to B and second one goes to D is only in the option A. So with the best option for this will be is equal to A. You no need to solve for the remaining options. So time saving method. But generally it is cheyali mar రావాలి అంటే. So third and fourth options కూడా ఇలాగే చెక్ చేసుకోండి వస్తాయి మీకు. You will get third and fourth options also in the same manner. But anyway, problem solves with only 2, 1 and 2. You don't need to spend the time here. Okay, go to the P9th problem. So P9th problem as follows. So it is based on the Huygens principle, law of refraction. So this problem, you need to remember one thing is, when I have the wavefronts, locus of all points which are in the same base. This is the plane type. These are the plane type. Then definitely I have the rays. Definitely I have the rays will be like this. Will be like this. These are the wavefronts. These are the rays. Rays which are always perpendicular to the wavefront. Okay, fine. Now, so in the problem they have given like this. There is a boundary separating the two media, that is X and Y. Now this is the wavefront which is coming and falling here. This is the wavefront named as A and B. The wavefront A and B. So we can draw the normals here. So let us take the pen, is a red color pen. I am drawing the normal here. This is the normal to the boundary. Now I can draw the normal to the wavefront. That is the normal to the wavefront as follows. These are normals to the wavefront. These are normals to the wavefront. So what is this angle is important for me. So normal to this. Normal makes an angle. Let's say this angle. This angle is, I'll take theta. Then this becomes 90 degrees minus theta. Then this is obviously theta. This is what they have given. Now this ray here, after meeting the boundary, again I draw the normal. Let us draw the normal at the boundary. I am drawing with the normal. Now there is a refracted pattern of the, this is the refracted wavefront. Incident wavefront is this. This is the incident wavefront, and this is the refracted wavefront. And this refracted wavefront, let's say, again makes an angle with the incident ray. This is the normal I need to draw here. So normal means which is perpendicular to this. Let's say which is perpendicular to this will be here like this. This is the refracted ray. This is the incident ray, which makes an angle theta with the normal. Now I need to calculate this angle. Let's say refracting angle I'm taking as phi dash. So this angle is again 90 minus phi dash. 90 degrees minus phi dash. This angle will be phi dash given in the problem. So this is the angle of incidence. This is the angle of refraction. Now apply the Snell's law. So in the air medium, it is 1, that is sine theta. In the medium, it is mu, that is sine phi. So from here, I need the mu. That implies mu will be is equal to sine theta divided by sine phi. So this is the answer for, sorry, this is the answer for refractive index. So Huygens principle ganaka meeru NCERT book or otherwise HC Verma book ganaka chadivinte ఇది చేయడం ఇది NCERT book or HC Verma book ganaka మీరు Huygens principle చదివింటే ఈ క్వశ్చన్స్ సాల్వ్ చేయడం చాలా ఈజీ. ఈ ఐడియా మీకు ఉండాలి. వేవ్ ఫ్రంట్స్ అండ్ నార్మల్స్, మనం లైట్ ఈస్ గోయింగ్ ఇన్ దిస్ డైరెక్షన్ అంటుంటామే, అవి నార్మల్స్. వైబ్రేషన్స్ విల్ బి పర్పెండిక్యులర్ టు దట్. ఓకే, నౌ వి గో ఫర్ ద 10th question.